Hello everyone, this is KP the Math G giving you some more calculus problems. This problem here is a 2006 free response question number 6, and believe me guys and ladies and gentlemen, I try to find problems that perhaps maybe you've done before, maybe you just need a refresher on those. This is probably one of those questions. This is one that should be easy. There's two parts to this, but believe me, you still have to think a little bit about what you're doing. And then there's some that I found that parts of which are fairly simple, you've done before, but then there is one section there, like a part C that's, oh boy, you really have to think about it to be able to do it. So be that as it may, those are the kinds of problems that I want to give you. This is a slight twist. I wanted to look at it. I have part B on the other side, so let's get to it. Given twice the differential function defined for all real numbers and they meet these three conditions: f at 0 equals 2, f prime at 0 is negative 4, and f double prime at 0 is equal to 3, and g at x is equal to e to the ax plus f at x. So A part says find g prime at 0 and g double prime at 0 in terms of A. Well, let's do just that. G prime, alright, since we're having to find g prime at 0, we need to find g prime at x. Now, let's think about it. If we had y is equal to e to the 3x, what is that derivative? Y prime is equal to e to the 3x times, now the chain rule says the derivative of 3x is just 3, which is 3e to the 3x. So if I had y is equal to e to the ax, then y prime is equal to a e to the ax. Alright, so that is one derivative you need to be familiar with. This should not be a very difficult problem, but sometimes we forget even the easy parts sometimes. And I have noticed the students sometimes, well, they'll just look at them, I can't do that. Don't be that student, okay, who will look at this and say, oh, I can't do it. Yes, you can. If it says g prime at 0, you know how to find the derivative of this. You can. So on this one, this is a e to the ax. What's the derivative of f at x? Well, it's just f prime at x. That's it. Now, if I want g prime at 0, well, I'm just going to plug that in. A e to the a times 0 plus f prime at 0. Alright. This is, alright, a times 0 is just 0. So this is a e to the 0 power plus, well, f prime at 0 is negative 4. So let's see, this is a times, what's e to the 0? You got it, negative 1, isn't it? So that is 1 plus negative 4, which is simply just equal to a times 1, which is a. And if you want to say plus negative, or just make it minus 4, there it is. So g prime at 0 is a minus 4. Simple as that. Alright, well, let's erase everything, and then let's find g double prime at 0. I have g prime at x, don't I? So I'm going to erase everything but that problem. And I'm going to do g double prime here. Okay, so let's do that. Alright, here's g prime right here. Well, g double prime, now if I had y equals 3e to the 3x, isn't that y prime equals 3e to the 3x times 3, which equals 3 times 3 is 9, e to the 3x. Or we might say that's equal to 3 squared e to the 3x. Okay, if we wanted to do that, right? So let's see what we have here. Alright. So this is equal to a, and let's go ahead and just put that e to the ax times a. Derivative of ax is a. Alright, now what's the derivative, the second derivative of the first one? Yeah, it's f double prime. See, don't make this difficult. Now this is equal to a squared e to the ax plus f double prime at x. So if we're looking for g double prime at 0, I think so. Alright, yeah, we're looking at g double prime at 0. This is a squared times e to the a times 0 plus f double prime at 0. Well, I have f double prime at 0, don't you? Alright, so this is equal to, equals a squared, this is a times 0, which is 0, so e to the 0, f double prime at 0 is 3. Alright, so this is a squared, e to the 0, as we pointed out, is 1. So plus 3 is a squared plus 3. And there they are. So g double prime at 0 is a square plus 3. Alright? Alright, there's that. It's just, that's what you do. I mean, just as simple as that. That one should be, I mean, that one was worth, by the way, 4 points. Okay? Point for the derivative, point for g prime at 0, point for the second derivative, a point for g double prime at 0. 4 points for that. Pretty good, isn't it? Alright, so some of these are easy pickings if you just know derivatives just a little bit. Now I want you to look at this. Here's the b part. H at x is cosine kx, where k is a constant, times f at x. If I do a derivative of this, which I'm going to find out if I have to or not. Yeah, it does. It says find h prime at x. Well, this is, alright, that, isn't it? And then write an equation of the tangent line to the curve of h at x equals 0. Well, I know that h prime at x. Now remember, if I had y is equal to, I don't know, let's say a and b, where a and b are not constants, they're numbers, they are some function like x, or you can cosine or sine or whatever, or e to the x or whatever. Remember that y prime, this is a product rule here, this times this, so it is the first times the derivative of the second plus the second times the derivative of the first. Simple as that. That's what you got to remember. This is a product rule. Okay, so just don't look at this and say, I can't do it. Think about what this is. It's a product. Oh, I know how to find h prime at x. It's a lot easier than I thought. You see, sometimes problems can be a little easier. That's why I wanted to throw this one in there, so that this would kind of give you a little bit of hope there. Alright? I mean, sometimes you need a little boost to think, I can do this. I really can make this. Yes, you can. Alright, so let's do it. The first. Alright, so let's do the first times the derivative of the second plus the second times the derivative of the first. Okay, that's what we're going to do. So the first is cosine of kx. Don't worry about that. That's it. Times the derivative of the second. Well, what's the derivative of f at x? It's f prime at x. There it is. There you go. Now the second is just f at x. Now the derivative of cosine, this is a chain rule, remember, as you got to do inside that later as well. You just got to remember, excuse me. Alright. You just got to remember what the derivative of cosine is, so that is negative sine. I memorize it this way. I remember that the antiderivative of cosine is sine, so the derivative of cosine is negative sine. Okay, I don't know, that seems to click with me. Now I need to take a derivative of kx, which is just times k, so times k, like that. Alright, now don't multiply k times kx right there, just put the k out in front. So if you want to, you can say this is equal to cosine of kx together, alright, kx times f prime at x plus alpha at x times negative k sine of kx, like that. And if you wanted to, you could put the minus here, make the plus a minus sign here. Alright, so now I've got to remember that f at x, or f at 0, I've got to remember what f prime at 0, and I've got to remember what f double prime. Well, I don't think I have an f double prime. I just need to know those two right there. Alright, so let's go back again and this thing over. F at 0 is 2. F at 0 is 2. F prime at 0 is negative 4. Alright, F at 0. F at 0 is 2. F prime at 0 is negative 4. I don't have an F double prime anywhere. Okay, so, alright. So now I need to know what h prime at 0 is. Alright. I am trying to find the slope. This is the slope of the tangent line. I wrote this down, okay, and I wanted to kind of write it in a way. Alright, alright, so I want h prime at 0. I've got, this represents the slope of the tangent line, and it does say at x equals 0. Alright, so that's what I want to do. Alright, so at x equals 0, I want h prime at 0, cosine of k times 0 plus f prime at 0 plus f at 0 times, don't forget that's a times, negative k sine k times 0. Alright, cosine k times 0 is just 0, cosine of 0, isn't it? Alright, so cosine of 0 plus f prime at 0 plus f at 0 times negative k sine k times 0 is just 0. Now we got to remember what cosine 0 is. Alright, so remember, cosine graph looks like this, and cosine of 0 is 1. Alright, so 1 plus f prime at 0 is negative 4. Negative 4. I'm thinking I should have a times sign here. Yeah, times. This should be times. Product rule. Times. Times. That's better. That looks a lot better. Plus, now, f at 0 is 2. Don't know if that's going to matter because what's the sine of 0? Alright, let's see. Just remember your graphs of sine and cosine. Alright, so if you drew the graph of sine, it would be like that, wouldn't it? And so, sine of 0 is 0. Alright, so that's it right there. Well, what is all of this? Negative k times 0 is 0. 2 times 0 is 0. 1 times negative 4 is negative 4. So the slope is equal to negative 4 when x is 0. Okay, that's what we're doing. So the slope, and we have not found anything but the slope. The slope is negative 4. Alright. So m is negative 4. Alright. Now, let's find out how to find the slope of the tangent line. Alright, so let's erase this. We did all of this just to get the slope. Let's see. Probably need that right there. Well, I don't now because I already know what the slope is, so I did my job here. Okay. Yeah, this is good here. Alright, I don't need any of this anymore. Bear with me while I erase this as best as I know how. Now, when it says find the equation of the tangent line, well, I know now it's y minus y1 is equal to m times x minus x1. Okay. Alright, now I need to know, I've got my slope. I know that let's see. I need to find out h at 0. Alright, so h at 0. Alright, still looking at that. That is cosine of k times 0 times elf at 0. Well, elf at 0 is 2. Now this is x. Alright, I'm finding out what y is right here. This is actually y. Alright, so now I have cosine of 0 times 2, which is h at 0, which, by the way, is y. So y is, cosine 0 is 1. We have already established that. So 1 times 2 is 2. So y is 2. And we should already have had that. Elf at 0 is 2. So h at 0 in this case is still, well, we had to find h at 0, not elf at 0. Just so happens that h at 0 is also 2. Alright, so y is 2. Alright, that is actually y1. We know that x1 is 0, isn't it? Okay, so here we go. Y minus y1, which is 2, is equal to that slope that we just found is -4 times x minus 0, and this is y minus 2 is equal, and x minus 0 is just x, so -4x. I think you could probably leave it like that, but if you wanted to just go ahead and write it in slope intercept form, okay, slope by intercept, okay, there it is. There it is right there. Adding 2 to both sides, -4x plus 2. I think you could leave it like this and be okay, just as good. Well, that takes care of it. I mean, there's a little bit more involved here. Finding the h prime, finding h at 0 to be that slope at 0. That's when we're saying when x is 0, we had to find out what the y value was. Y is 2, x is 0. Don't just go by this. F at 0 is 2, I get that, but, well, so is h at 0, 2 also. Alright, so it just happens to be that way by a coincidence. So just by simply putting this in here. Okay, alright. Now this been signed right here, h at 0 would have been 0 times 2, which is 0. So, okay, just kind of be aware of that. Alright, so that is all that I have for today on this video. Sometimes you find that things, you know, are not quite as hard as they look. And I chose this video for that very reason, because it is not altogether as difficult as we may foresee it to be. And you look at this problem right here and you think, well, okay, all of this, you think, well, I can't do it. Yes, you can. If you were told to find g prime at 0 and g double prime at 0, that should be really quick and easy. And then, I mean, you got at least 4 points right there, okay? And then this one here is 5 more points, okay? I could find h prime at x. I could do that. H prime at 0, at least find the slope of that. And whether you could find the equation, you still got to remember the equation has got to be y minus y1 is equal to m times x minus x1. And then plug and find out what x and y are. We knew that we're looking at x being 0. We just had to find out what the y value is. And once we did that, we were able to plug everything in. Okay. Alright, that's all that I have. This is KP the Math G. Please subscribe if you haven't done so. And also hit that like button. That's a pretty nice pretty smile upon my face to see all of that. And also make a comment if you'd like to. I appreciate any and everything. If I could have done this better, let me know. But again, always be correct when you show it to me. And I will put yours up here and show you, hey, this was an easier way that I saw. Because it's not about me, it's about you getting better at this right here. And thinking about even the little things here like this product rule here. Okay? So again, I'm just here to help you out in any way I can. I hope I'm doing that. I trust that my lessons are helping you. So anyway, I'm just here to give you my best and my all. KP the Math G signing off. Ladies and gentlemen, have a great day.